design communication, how we approach cartography, our approach on interactive work, some of our work on public and open space data, and then time for questions at the end. So GreenInfo Network, as far as we know, we're the largest dedicated nonprofit GIS support group. That's not a huge pool to be the largest of. We're 12 people we've got one person in Vermont, someone in Seattle, one person in Corvallis, Oregon, and the rest of us in Oakland, California. We were founded in 1996, so we just completed our 20th year. We've served somewhere between 800 and 1,000 organizations. We just did the tally for last year. We did just over 200 projects last year for about 100 clients. We have a special a niche in the conservation, protected lands, land trusts, environmental mapping, that sort of thing. And so our mission really is about bringing the power of mapping, information, and communication technology to nonprofits and other public good causes. And as you can see on the right there, that's a poster we did for a prospective protected area and even a national monument campaign in Northern California. We're really focused on visual communication that uses spatial data and cartography, less so on in-depth GIS analysis, although we do some of that. And so really we focus on these areas of conservation, environment, and social well-being. How do people connect to place? How do people connect to land? And how do we understand how land and place affect the health of communities and people? And so we work across a range of, our clients are mostly nonprofits, some government agencies across a range of sectors that cover these areas. So designing communication for us, the reasons to make maps and to publish maps is really to achieve goals for our clients. And those goals are usually related to some sort of public audience and public perception, whether it's a political campaign or research with a public bent towards policy around park protection or park accessibility, that sort of thing. And so we really focus on message and goals. We focus on how users are going to interact and really understanding who those users are. Are they the general public looking at this on a website? Or are they interested parties from smaller conservation groups gathered in a room at a hearing of some kind? Are they technical users submitting applications for funding? And that really frames everything we do with GIS, maps, reports, websites, and mobile apps and various things. And for us, really, we try to be fairly ruthless about the fact that people don't have to look at our maps. Generally speaking, there's very few things that we make that people are required to look at. So it's very optional. So we need to get their attention in less than a second, and we need to give them something, their eyes, something to grab hold of in 1 to 3 seconds. And it's only after that that they really start to dig into what is this map about, what is it trying to tell me. If we don't catch their attention with some clear hierarchy of information and some bold contrast or color, they're probably going to move on and get on with the rest of their day. People just see so many images in our culture now, especially. This has always been true, but every year it seems like we're just inundated with more and more visual imagery and more kinds of visual noise as well as visual signal. And so we work hard to try to make sure that our maps have as much signal and as little noise as possible. So this is an example of a map with undefined message on the left, where we really focused in by changing the title to something shorter and clearer, and really focusing in on the schools areas and these red dots where there's tobacco sales. And so we look at typography, the actual wording of titles, color balance, shading back non-focal areas, all kinds of things to try to make things stand out. And then again, we do that across both print, interactive, poster maps. This is an image of a report that we developed for California state parks that accompanied an online tool for their statewide comprehensive outdoor recreation plan that allowed mapping of park accessibility across the whole state, for any community in the state. And for this, the print report, we knew that our users were mostly going to be flipping through, so we made really simple maps. We used a lot of bold photography with people, and these are basically legislators being handed this report and then flipping through it, and they weren't going to get into appendices and footnotes and deep complex color palettes on the map, so we just boiled it down to the absolute simplest possible thing. And of course, you have to make sacrifices to do that. You can only show one or two variables on a map. You can't show everything. You might need more maps to show more things, and you really have to be ruthless with yourself and disciplined about what's the most important thing that we need to communicate. What do we have to communicate? And so again, that's really what we're always trying to focus on, is what are the key messages, and are we succeeding? And often a question of, is there anything that we need to take away more often than add to get that message across? And it's always an interesting journey with our clients, because especially when they tend to know a lot of the spaces that we work in even better than we do. So when we're working with a public health group, they might know that data better than we do. But then we help them really pare it down to the essentials, and that's a lot of our job. And so how we approach cartography in particular is again really this refined design approach, custom client-driven projects, and across a wide range of topics and messages. A bullet that I should have here that I don't is we try to build on top of client branding and look and feel whenever we can. We like to say even internal maps should look like they belong to the organization that made them. So we work with a number of land trusts and other nonprofits, even if they have in-house GIS staff, to develop for them map templates, so that when they make maps for their board or for their leadership, it always looks like that map came from the Peninsula Open Space Trust or whatever organization we're working with. And we like to think that even the internal visual consistency of that Carto styling and branding makes a difference in how people think about maps as a visual artifact and as an important visual artifact, and not just something to sort of crank out. And so here's a map that, to us is not clear message. There's sort of stuff all over the page, and it's a lot of different kinds of colors and things and labels being thrown at you. And this is one where we did this won some recognition from the North American NACIS, North American Cartographic Information Society, where we took demographic data and clipped it to building outlines, so that when we start to show what is the ethnic breakdown of San Francisco, we actually show that information where people live, right in those buildings. So, partly that's clipping out parks and other things, but also even in areas where there's sort of lower building density, we tend to show less. And so using a sort of creative approach to give some visual flair to this thing, while also matching the color palettes of the Metafund, the foundation for which we made this map. This is a close-up of that map where we clipped the building outlines and used that to sort of really give a texture to the map that's also meaningful, since it does show where this is a map about people, and we're showing the buildings in which people live. So that's the kind of thing we try to do. Here's one where we really try to focus in, and the two shades of purple here are the most important thing. So we really wanted those to stand out. And obviously the shape is the project area that we were talking about for this organization. And so we used border shading to make that happen. And by the way, these are generally all our maps are made entirely in our static maps or print maps are made entirely in ARC and not through Illustrator. Occasionally we pull out into Illustrator, but very rarely. We find that we can achieve excellent results within ARC while then also maintaining easy data updates, because once we drop out into Illustrator, obviously that introduces its own issues. And here's a close-up of that map, where we've got this border effect that really pops out the area of interest, and then we echo that color, that purplish color in this further area. That's the most important part of the map. So again, just really working with clients to understand their data, but also understand their messaging and foreground what's important. So this one is a map we did for the National Audubon Society for their Audubon magazine, and this is one. I'll just they provided all this data about issues in the Arctic for a special issue that they did in January 2016 about impacts of climate change and industrialization in the Arctic. And it was really this red line down the middle that was the most important thing. And so we wanted to really make sure that we made that clear and had it running sort of front and center. And they had actually supplied us with an incredible amount of data that suggested if we were making an interactive map where we would have shipping lines all over this map, and one could imagine time series and other really interesting approaches, but we knew we had this one visual image in a print magazine to make this for, and as much as we were sort of tempted by that amazing sort of chaos of individual ship tracks that ran all along this, it sort of muddied the message. So we had to restrain ourselves and really focus in on that key message. And so that's often part of the process where we'll churn out a lot of different variants, and then we end up with something really, really sort of solid, clear, and refined like this, that's ready for publication. On the interactive side, we take a fairly different approach in technology. We use an entirely open source stack. So a lot of data, the Postgres database, JavaScript, and a little bit of D3 on the front end, and actually use a technology called Map Server for a lot of our data layers. And a similar design approach. We try to be user first. I find this is even more challenging on the web, since theoretically you can add as many layers as you can list checkboxes on a map and just let the users choose. And we find that that's just not, to the extent we can avoid that, we do, because again, on the web we still have that less than 1 second, if that, to grab people's attention, and it's so tempting, and we don't succeed at this 100%. It's our ambition to never be data first and always be user first. I mean, you have to have the data to serve the users, but if you're building the application around the existence of the data, then you're probably missing your chance to really make something usable. So when I find when you have an application with a left bar that has 14 nested lists of 20 or 30 layers each, I mean, unless it's meant for highly technical users, chances are you're not going to get a lot of people really understanding what's the data story you're trying to tell. And then mobile responsiveness is becoming more and more important, and one of our sort of unique or relatively unique aspects is often creating web products that produce printable artifacts, essentially PDFs, and I'll talk a little bit more about that. Going back to this is a print report. This is a website to accompany the print report that we created for state parks. And again, when you get here, you don't even know that it's a mapping-related thing. It's very much photo-oriented, all about people connecting to place, because that's the message of state parks. But then when we get into the maps, we are able to basically give people a specific report for how many residents of California live further than a half mile of a park, and how many have fewer than 3 acres of parks or open space per 1,000 residents, which are the metrics the state has identified for park adequacy. If you live within a half mile of a park and you have 3 acres or more per 1,000 residents, then you're considered park adequate. And so that data is fairly simple, but because we have it wall to wall and we have parks data wall to wall, and I'll talk more about how we got that parks data later, we're able to create this really simple tool where you can drop in a city, a county, a legislative district, and get information about that. And so we can look at how many residents of Compton in South LA live within further than a half mile of a park, and how many have enough parks. And so we can see a lot of them live within an acre, within a half mile of a small park, but very few of them actually are park adequate. And so you can imagine that city government folks, legislators can really use this to advantage, to understand how their community is faring. And we did this work with State Parks office here in California called the Office of Grants and Local Services, and their job is to distribute funds from federal and state sources to local park agencies. So their audience really is the officials from park districts and city governments and county governments and special districts, sub-state level park agencies basically, to understand how they can marshal resources for park improvements in their communities, and also how their communities are faring relative to other communities. So this project really made that happen, and it was a fairly innovative project, especially coming from the State Parks Department here. They were just reminding me yesterday in a meeting actually that they went out on a limb when they did this, because you can imagine that there's probably 1,000 other ways they might measure park adequacy, and they really zeroed in on these two metrics and said, simpler is better, and understandable and clear is more important than totally comprehensive. So I really, we sort of tip our hats to them and give them a lot of credit for this work being so effective. And the other thing we did is crossed our parks data with census information to allow them to ask their grant applicants to basically get a report of the community information within a half mile of their location. So when a applicant wants to get funding from the state for a parks improvement project, it used to be that this was all done somewhat by hand. They would submit an application with an address. The parks officials would figure out where that address is and do some simple intersects with census information to tally up this data. But of course, it's essentially grunt work. So we automated that process, and anybody submitting for an application has to put the location of their proposed project here, and they get this report. They can preview it and see, do they think they're going to qualify? We have this overall information here, and then we have the park adequacy here. So this area by parks per thousand would qualify. And so then they can get a report, and that registers an ID number in the system, and then they submit that PDF with their application, and that ID is on the PDF. And actually, I have the PDF on the next slide. So that produces this sort of printable artifact that then travels along with their grant application. And from the state's perspective, this is a godsend, because it provides basically an automatic track record of the spatial and demographics data that went along with why they did or did not fund this project. And from the user perspective, it's maximum transparency. They can drop in different potential locations for their projects that they might have across their community and see pretty instantly how those locations compare to each other. So this is a project that I think really leverages. Ultimately, it's not that complicated at all. It's pretty minor in terms of what the GIS work is, but the effort involved in understanding the problem and working with innovative folks on the state park side to really make this kind of approach work has paid off a lot. And we're already starting to talk about the next version of this. They have to do a version of this kind of plan every 5 years. So we're looking at what sorts of innovations can we take in the next version for 2020. This is a project that we did with an NGO in Oakland, and this project, I just realized this slide doesn't actually even have a map. Interesting. Oh, I think I had a transition here that got gobbled up by my importing of the slide. Sorry about that. And this is a map and dashboard for the climate greenhouse gas emissions funding. That's the cap and trade funding, in California. Basically, people have to buy credits, and then that money is used for things. And we're able to slice that by county, legislative district, air district, other spatial slices and provide easy reports, and this dashboard updates, and it also looks really nice on a phone. So as soon as they get there, again, this is part of the idea of we could have gone really map-centric here, but really we wanted to get them these big numbers immediately. So as soon as you get to the site, you get this overall impact report. Like, okay, there's a lot of money here and a lot of greenhouse gas reductions, and I really can't miss that. And so that that was really the design goal there, to make sure that whatever spatial slice they're looking at, they get these overarching numbers. And this is a product we did. This is the web version. I'll flip back to this in a second. This is the mobile app version. This is trails in Pitkin County, which is Aspen, Colorado. And this is a case where our work was really assisted and aided by the quality of this particular county's GIS data. Their trails data was really in good shape. It was topologically correct, so we could build routes. Basically, you can click on lines and get routes and get elevation profiles and things like that. And you know, that was work for us to do. And so here's one where they've chosen a particular loop, that was work for us to do, but it was made possible really by the quality of this particular county's GIS data, which is really fun. And this is a project we're doing. Again, this is San Diego parks. Again, we do a lot of effort where once we have all this wall-to-wall data about parks, we can then do a lot of different things with it. We can help the state of California understand park equity and equitable distribution of funding on the one hand, and we can also build public-facing park finders for particular regions or maybe even for the whole state. And this is, we actually developed custom base map tiles for this and other parks-related applications to use on the web. That's using Mapbox Studio technology so that we can have accurate parks data, and the maps are incredibly fast and inexpensive to host. So that's probably the most interesting cartographic piece here. Those are vector map tiles that we're able to feed into our open source projects and use over and over again, and easily update those every time we update our protected areas data, which is every couple of years. And then the other thing we do is we build tools to help non-GIS users contribute or verify GIS data. And so this is a Map Collaborator, is a product that we've developed over the past about 5 years to use for various purposes. This one is for editing, public editing of our, recommendations of edits for our California Protected Areas database. And we use simple and freely available mapping technologies, our own custom base maps, but then Google Street View and Bing aerial, oblique aerial bird's eye. And it's just incredible what we're able to verify using this sort of simple tools. And people can log in. We built a variant of this system for a recent parks needs assessment in LA County, where we were a subcontractor to a larger firm called Placeworks, and they used our system to survey over 100 cities and their park facilities and facility quality and park boundaries, and basically all the smaller communities. LA City itself just gave us a big data dump, but for the smaller cities that didn't even necessarily have any dedicated GIS staff, they were able to log on to this system and make notes and mark where their parks data was erroneous, and also to submit reports about how many playground structures they had and how many ball courts and various things and what condition those were in. And that data, along with a lot of other work by other contractors and government folks in LA, led to the successful passage of a really large local bond measure to support parks over the next decade or two. So that was a big success of sort of controlled crowdsourcing of geospatial data and also data-driven parks funding. So from our perspective, it was a win all around, and certainly compared to that several $billion, the investment that anybody made in Map Collaborator was on the order of tens of thousands, not very many tens of thousands. And so we can also use this as a simple viewer to just quickly put up layer viewers, which we do for clients in particular, where they might have one or two GIS staff who are tired of being asked for 1,000 different things, and really there's just other non-technical staff that need to be able to fire up a web browser, not worry about logging in or having accounts and things like that, and just see a bunch of data that these agencies use regularly. So this would be sea level rise data that might be used by our Bay Conservation and Development Commission, and this would be more of an internal tool than an external communications tool. And so this Map Collaborator platform, we've found sort of infinitely variable uses for it that have come in handy over and over again. And the last thing I want to talk about is public data. And so we've developed public data sets related to parks. In California, the California Protected Areas Database has about 55,000 holdings in it from 1,100 agencies. That accounts for about 14,000 parks. I think it's about 49% of the land area of California. The California Conservation Easements Database, that's been a more challenging data set to build, but we just released in December a version that has another 500,000 acres in it. And then working with researchers at Stanford, we did parcel aligned maps of every school campus in California. And that data had never been assembled before. And that's an interesting one because the funding for it actually came from tobacco harm reduction funding, I think from the feds. And so the researchers at Stanford's interest was that in the past, the school locations are reported by the state as a point, just a geolocated point based on the address. And sometimes those are wrong, they're in the wrong place, and even when they're correct, it's one point on, say, a 10-acre campus, and then public health researchers put a 2,000-foot buffer around that to decide what should the tobacco-free zone around the school be. And you can imagine that once you start mapping parcel-aligned boundaries for school campuses, that 2,000-foot buffer changes significantly. So we just launched that in December, and we've been excited to see how it will get used. And then more to interest nationally is that we're a key partner on the Protected Areas Database of the United States, which is the national effort to catalog all the protected lands in the country. So in California, that's really the heart and the model of the work that we've propagated up to up to the USGS in how to be a steward of protected areas data on a statewide basis. And this has grown over the last our entire history started as a regional project in the Bay Area and has grown to cover the entire state. And we do 2 releases a year. We do a lot of updates in each release. We are working forever sort of chasing many different agencies for new data and also trying to improve what we have. And so again, it's 49 million acres, 14,000 parks, and basically really trying to give a sense for any kind of multi-agency planning and regional planning, and certainly statewide planning, the existence of this data for any particular project, it's completely unsupportable to gather this level of data across an entire state. But once it exists, then you can do some of the things that I've shown before of regional park finders, of regional conservation planning, of statewide park equity planning. Once those inventories exist, then suddenly many, many more things are possible. Making them exist is an interesting challenge that we've been tackling for a long time with success. So these are some of the agencies in our inventory, and as you can see, the federal lands are the largest and biggest, but how these sorts of public data sets come together. So this is also roughly true at the national level, where fee-owned lands are just in such better shape than easement lands. Like we have a really long way to go to understand easements, and we've been talking to folks here around. They're very important to know about, obviously, in terms of conservation planning, regional planning, even fire protection. Just a lot harder to get. And then the other thing we often struggle with is how to manage restricted and closed properties, but luckily most of the lands are open access. But certainly as we start to release this sort of data into more different kinds of uses, in recreation use in particular, in public data consumption, as opposed to just feeding it to GIS professionals, we have to be more and more careful about how we represent restricted and closed properties. Some of the other things we work on in this regard is that relatively few agencies own most of the land, but the most people in terms of urban areas interface with some of the smallest agencies. So depending on priorities, and certainly at the national level, it's been much easier to gather federal land data and state level data than community level data. And so we've been working on that community level, a framework for that with the USGS, and also the Trust for Public Land is very active in that as well. And how we structure the data, it's not so simple to figure out what is a park. And we've over many years we've developed this sort of holding units, super units framework, where at the left side is really what GIS professionals care about, and the right side is what the public cares about. And keeping these things straight, we've also really worked hard to start to have persistent IDs over super units and units, so that for recreation uses, particularly for web developers who are attaching additional data to our data, so they might append data about various recreation activities you can do to these parks, and we don't have to make that part of our core schema if we can tell them that super unit 1093 is always going to be super unit 1093, or we're going to publish a change log, and you'll be able to understand what the new super unit is. And so then they can have an independent data set that they can rely on connecting to our spatial data, and in that way we can sort of take the pressure off of the core data to have every different field it might need. So let's see, I guess I went through my slides a little more quickly than I meant to. That's GreenInfo. I think the interesting thing, I should have had some more slides in here about the Protected Areas Database of the U.S. We just released a progress report and prospectus on that, and a technical paper with USGS, and basically protectedlands.net is the place to go, and you can get a report for any state and how that's doing, basically how complete is the data state by state, and to understand a state by state view of how each state is performing and who in that state is the data steward for that project. And so we've really tried to use our work in California as the model for this national effort to complete a nationwide inventory of protected lands, and all in the purpose, obviously, of figuring out how to communicate to people about the value of protecting lands, and whether that's recreational values, habitat values, or other values. So that's GreenInfo, and I think I can open it up for questions now.
Dan, great presentation, excellent GIS application and tool in how to use the data, not only just for the GIS individuals, but also for the community at large. And it's a great asset in that. From that and everything, if anyone has any questions, please type in the comment below, and Dan will go through and answer as they come along. Also, just to let you know, this recording will be placed up on YouTube and also on the New York State GIS Association website for those that are members. Those who are not, please, it's a mere $10, plus we have a 5-year plan on that as well, if you want to do it as one lump sum for 5 years. So please take advantage of that if you're not a current member of our association as well. And we have a couple questions coming in now, Dan.
Let's see. What's our preferred? This is going to be the pitfall of having the executive director of an organization do the presentation. So the preferred file type for exporting from ARC really depends on what we're going to do with it. So we often export straight to PDF for prints, and that's and then when we have to, we can open those in Illustrator and deal with them, but we rarely do that. And the border shading is done in ARC, creating shapes. I wish I would instant chat with some of my colleagues to understand the exact features that they're using to create that border shading, but I don't think, oh, let's see, I have one guy in Vermont. Let me see if I can find out exactly how we do that. Other questions while I track that down?
When is your new version going to be coming out? I remember you saying, remarking that you'll be working on a new one here soon.
Sorry, new version of the parks data?
Oh, of the parks data, yes.
Well, so in California we release those twice a year, once in June and once in November. So the next release for our California data will be in June, and we just did a PADUS version in the fall, and that they're trying to get to an annual release schedule for PADUS. That one's a little more challenging, so I wouldn't expect a new PADUS for a little while. I'm not quite sure when. One of the big efforts on the PADUS front is sorry, I'm getting an answer to the glow. One of the big efforts on the PADUS front is to work on a sort of 2.0 data format that also tries to solve some of the issues around unique IDs, and it's a huge challenge because the data comes from so many different sources, and they may or may not have unique IDs, and yet particularly for interactive and web uses, having unique IDs over the course of multiple releases is really important, and it's a challenge. So the buffers are vector multi-ring buffers that with 10 to 15 different rings that we produce directly in ArcMap. So that's how we make those sort of shaded shadows that make the figure ground relationship really stand out. And as far as the other question was about building Carto skills. Our website, frankly, not to be too self-promoting, but it's free. If you go to greeninfo.org/work, you'll find about 220 different projects that we've done over the years, just tons and tons of examples, and it's easy to sort and filter by different focal areas, and we have a whole GIS area as well as an interactive area, so what you're interested in. And then, the NASA's Atlas of Design is really great. then, I mean, personally, I keep an eye out on some of the major media sites, frankly, for really innovative uses of simple maps. I mean, the way the New York Times data desk uses things like small multiples, where each map has only one layer on it, but they have 30 of them. And a lot of that stuff, they're doing it in an interactive format, but I've noticed over the last 2 or 3 years especially that a lot of the interactive mapping at the Times has become more and more print-like. And you can really see how they're simplifying and making their maps, each individual piece, do less, while the overall impact is more. And so I find that really useful to study, where it's like, wow, they're able to communicate these incredibly complex concepts with 2 or 3 colors and some lines, and then it's about having 3 or 4 different maps that are put together in a thoughtful sequence. And we're just about to launch a project in the next week or two. Again, California focused, so much of our work is, but one that we're basically doing a scrolling story. It's inspired essentially by a story map approach, but we wanted, in some ways, even more control over what's happening. And Tim Sinnott, who's one of our most innovative cartographic brains, is developed animations out of ArcPro that we then used basically a scrolling animator library, so that as you scroll, they animate. And this is, I wish I could actually show this. It should launch a week from tomorrow. And in that case, we were able to make one map showing coastal parks in one way and one map showing coastal parks in another way. And you scroll down the page and you see this happen. And it's interesting to me as a practitioner to see how, in some ways, web and print practices are converging because of the need for simplicity and the scarcity of attention on the part of users. So that, you know, scrolling down the page, and the animation obviously is not something available in print, but the idea of making sure that, you know, it's better to have 3 maps each doing one thing, perhaps, than one map doing 3 things. And that's not always true, but and certainly with 3 it's debatable. But if it's 12, then it's probably better to have more simpler maps that you're presenting with context. And that's something that we're really pushing on right now, I would say, in trying to absorb that. And I see a sort of a trickle-down effect that happens as we see leaders like the Times or Nat Geo doing this sort of work, and then we slowly sort of absorb that and then start to see, okay, how can we make that work for our clients at much, much lower budgets and much faster time frames? And so, you know, keeping an eye on what journalists are doing with mapping, to me, is, I mean, it's partly because my history as a journalist, but that's one thing I really try. Any details? Let's see. I will say, Paula, if you want intimate details of how we do those shadows, I now have them in my instant message. Maybe I'll just drop them in the chat at the very end. So our online maps, we generally, we are a take-all-comers technology shop. We occasionally use Esri interactive tools, not very often. Mostly, I mean, part of that is because we work for, like I said, 100 or more clients a year, and very few of them have ArcGIS accounts or understand that ecosystem. When they do, and when they can benefit from, they're already storing their data on Arc Online, then we'll work with that and build technologies on top of that. But most of our work, we're using Leaflet to present maps. We've just recently started using Mapbox Studio on a few projects. Again, if you were to go to parkinfo.org, which I'll type in here, this is an example of Mapbox Studio custom tiles that we built. And Mapbox provides a lot of basic data from OpenStreetMap. You know, and depending on your tolerances and your needs, that can be good enough for a lot of uses. And then we pulled out all their parks. OpenStreetMap parks aren't good enough for us, so we got rid of all that stuff and pulled in our own parks layer. But it's incredible that previously, we built and baked all those tiles using traditional web mapping infrastructure, Mapnik, some other tool, Carto CSS, and hosted those ourselves. And it was so hard to keep them fast and running. And Mapbox Studio, the things are incredibly fast, and we don't have to worry about uptime. And I think it costs us a few dollars a month on top of some other client work that we have up on Mapbox. But for low traffic maps, you'd probably fit within their free tier. One of the other technologies we use some and sort of try to figure out is Carto.com, until recently CartoDB. And so most of our fully custom map products or web products are built with Postgres and PostGIS as a data provider. And it's incredibly powerful, and we've got a couple of developers who are really good at using it. And we host that on a dedicated web server. Carto is really attractive because it's essentially Postgres as a service. So without understanding how to set up a database server, without really understanding how to even set up a web server, you can start to load data and work with Postgres. The challenge that I've seen is that their business model has been shifting, and they've been going more and more towards higher monthly costs once you exceed their free tier. So for us, we have to be extremely cautious about putting clients on Carto. It works really well if they don't have internal GIS capacity because there's a lot of power there. And so as long as they're not going to hit the data limit, it's great and it's free. But as soon as you hit that data limit, it's over $100 a month. So, if we're doing, our budgets run anywhere from, for web projects, 10 to 25, maybe $30,000, occasionally bigger, but not a lot bigger. And so for those folks, it's, you're not going to pay $1,200 a month just for, or $1,200 a year just for a data server that's serving one interactive map. So we have to be careful about that. And we've also, we've started to bring more D3 into our practice in the last year and a half or so. And again, that's, when you look at what the New York Times Data Desk is doing and the D3 geospatial capabilities, there's just a lot out there. So that's probably more than, as you might guess, I'm bullish on open source web technologies. It's probably more than you need to know. Other questions? And let me just grab this. This information about the shadows. Oh, there's some timestamps in there that I couldn't take out, but that should tell you, give you a basic idea of how we're doing that.